young kids, there's no need to feel down. I said, young kids, pick yourself off the ground. I said, young kids, 'cause you're coming back soon. There's no need to be unhappy. Young kids, there's a place you can go. I said, young kids, learning math is the way. You can do this, and I'm sure you will find many ways to have a good time. There's no fun with COVID-19. There's no fun with COVID-19. You can still do tests. You can still do maths. You can still do your homework. COVID-19. There's no fun with COVID-19. You can still do tests. You can still do maths. You can still do your homework. Hey guys, we are doing using arrays for two-step experiments. First thing I'm going to tell you about is an array. Array is just a table that we use to list the sample space. When we do a two-step experiment, we can have something with replacement and something without replacement. Now, what I mean by this is, if I have a deck of cards and I choose a card at random, then I put it back in the pile, then choose another card, then that's with replacement. However, if I grab a card and then I don't put it back and then I choose another card, then that's without replacement. Okay, we're going to do some examples. Here's the first example. 2 letters are chosen from the word food. Okay, draw an array with replacement. So first of all, I'm going to write the sample space of food, which is F-O-O-D. Okay, and then because it's 2 letters, I'm going to write another sample space, F-O-O-D, on the vertical side over here. Now it's with replacement. So if I choose the letter F, I can put it back in and then pick another F. So I've got F, comma, F. Okay, so this is my first, and this is my second choice. Okay, if I choose F and then put it back in and then grab another letter, I can have an O as well. So I can have F, then O. Or because these are 2 separate letters, right, I can have another F and O, and then I can have an F and D. Now, if I choose an O, I can follow that up with an F. Okay, and then I can follow up with the same O, so O, O. Or I can follow it up with a different O, so O, O again, or an OD. And you guys get the idea. I'm just going to quickly finish this off. O, 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 D, D, F, D, O, D, O, D, D. Now the order is important because this one tells me my first choice and this one tells me my second choice. Okay, that's with replacement. However, when I choose a letter, I might do it without replacement. So let's write the sample space again, F-O-O-D. And yes, I chose food on purpose because the next lesson we will be eating some Smarties for our experiment. Now this time, if I choose an F for my first letter, okay, I don't put it back. So I've taken an F out. I can't choose another F. Okay, but if I choose an F, I could get an O. And then I could get another O. And I could choose a D. Now let's call this O1 and this O2. O1 and this O2 and O2. Now, obviously we don't have a difference in letters. However, if I pretend they're cards and it's one card, we're going to call this O1. Okay, if I choose O1, then I can get an F next. But if I choose O1 and I take it out and I don't put it back in, I can't choose that same O again. But if I choose the first O and I take it out, I can still grab another O. So I can have an O here, then an OD. Okay, but this second O, right, I can have an OF. If I take the second O out and I choose another card, I can still get that first O. So I can have O here. But if I take that second O out and then I don't put it back in, I can't get that second O again. So there's nothing here. Okay, and if there's nothing there, then we just put an X where we could have something. So D-O-D. Sorry, can't have that because I've taken the D out. I'm not putting it back in, so I can't have a double D. Okay, next part of the question is, Find the probability that the two letters chosen are both O's with replacement. So if we go over here to the with replacement array, there are 1, 2, 3, 4 outcomes that are both double O's. Okay, so 4 out of, let's count this, 1, 2, 3, 4 by 4 is 16. So that's 4 out of 16. Now, because you're in the 5.3 course, you should be able to simplify this without thinking. This is 1 over 4. However, if you're struggling with it, that's absolutely fine. Use your calculator, okay? Without replacement is this array here. There are 1, 2 that are double O, so P, O, O. P stands for probability, is 2 out of, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, once again, this can be simplified to 1 over 6, okay? Next one is find the probability that at least one letter is an O. Let's move this one down to the next line. Okay, one letter is an O. At least one is an O. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 P, at least one O. I think I said 12 out of 16. So there's still the same number of outcomes, the sample space. Once again, I can simplify this, and I should be simplifying this, and it's 3/4. Okay, let's check the answer for without replacement. At least one O. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was 10. So P at least one O is 10 out of, there was 12 together. We can simplify this into 5, 6, okay? So see how there's different answers with replacement and without replacement. So it's really important that you know which one you are doing, okay? So copy down the notes and start the exercises. Bye, guys.